Hello and welcome to Drakon video series. Today we are going to design a parametric ring using Drakon for Grasshopper. So in this case, when we open the Grasshopper, we will load the gem on ring component. So we just put it on the Grasshopper canvas, and now I just connect it to the display material. In this case, I just check the layer number. I want to use the number 4, which is the gem layer, so you can see for a better visualization. And now we will need to define all these parameters. So I just double click on the canvas to set, in this case, I will define the 3.0, which means that it's a slider. I will connect to the gem, in this case, gem length, gem width, and also gem height. Actually, for the gem height, I'm going to right click and set an expression which is x multiplied by zero point 0.6, which means that it will keep the height proportional to the any measurement we use. So that's the idea. So now again, double click and I said 3.0, so means that I will connect to the girdle distance. So you will see that we are connecting the distance to the ring size, and finally another slider which is the ring size in millimeters. So you can see wherever we change the ring size, everything will follow. So I can edit with the right click. Actually, I just want to make sure I use the decimal places. In this case, starting with a minimum, we can define any, but I will define, for instance, 10 millimeter, and maximum values for this slider. I will set, let's use 25. Okay, we can set any we want. So you will see now that I can adjust the ring size, so or double click and type exactly the measurements. So this is the idea. We have one component. Now we are going to use offset gem curve component, and I will connect the gem output from the gem ring to the gem input from the offset gem curve. You will see the curve by default is zero distance. So once again, I just double click on the grasshopper canvas, and I will set -1 smaller than this is the slide range, so smaller than 2.0. I just use 2.0 to be automatically one decimal place. Okay, so this is the idea. So now I will connect this to the vertical distance. You can see that I am adjusting the vertical distance. And now the idea is to actually control C, control V on the keyboard to duplicate the slider. And in this case, it's for the horizontal offset. So I will keep it on 0. So once again, control C, control V to create a copy of the offset gem on curve component. And now what we will do is actually I want to create this outside curve based on the original one, which means that whenever I change the original parameter, the other ones will adjust. So I just create here addition. So I will connect the horizontal offset value from the slider, and I will add 2 millimeters. Of course, we can change that value any moment. And actually, I just place here 2.0, so I can adjust the distance, any distance we want. So this is the horizontal distance for the second curve. And once again, Control C, Control V. Actually, I'm going to do from the first one, not the second one. And the idea is to use the values and be always based on the first one. As you can see, I can always drag with the Alt key on the keyboard to make a copy as well. And what I'm doing here, it's another, actually I create a division, and I'm going to connect the actually I'm going to add, my idea is to create a curve in the middle. So the idea is to divide by 2 the original distance. So what I'm going to connect is the first value is the original, actually the second distance, and then divided by 2 means that the middle curve it's for the third offset gem on curve component. Now with the gems on curve component, I just need to connect this curve to the gems. And once again, I will use the display material component to connect the gems so I can see the geometry. I will right click on the layer and set layer number 4 for the gems. And now we will, let's just, for instance, adjust here the distance from the second curve, and let's use this to connect to the gem size. So I'm going to connect either to the gem length, gem width, and also to the gem height. Remember the gem height, we right click and set an expression x multiplied by 0.6 to keep the height proportion. So whenever we do this, the gems will always keep the proportional. So as you can see now, whenever I change the curves, everything will adapt. So that's the idea of connecting the same slider to the other values. All these will be connected. So as you can see, we can create a parametric example easily using the grasshopper. That's the main advantage. We can connect everything, whatever we want. So we can create really complex geometry and all related to each other. So at this point, I'm just changing a couple of values so we can see how it all connects. It's connected and how it's affecting the geometry. And now I'm going to keep going. At this point, what I'm going to do is to actually create the base surface for the gem. So double click on the canvas and I will type loft. So in this case, I need curves to loft. I will make sure I choose the outside one. So one, and now we shift on the keyboard to connect multiple inputs. So as you can see, I create a loft surface. And once again, double click on the canvas to type extrude. So now I connect the loft to the base of the extrusion, and I need to set a direction for the extrusion. So I set the Z direction, but I need to set one value. So I'm going to type -2 smaller than 2.0. So we will see when we connect this value, it's the value of the extrusion. Okay, so let's say we want 1 millimeter thickness. We just put here -1, so it's the extrusion direction. And now we have a solid, which will be the base for the gems. So this is the idea. We are making everything connected to each other. This is the reason we are building this ring with the grasshopper components to be completely connected. So now I just select all of them and with middle mouse button to hide these curves. So the same here, middle mouse button and hide. And now what I'm going to do is to create the prongs. So I can select the prongs row, I connect the gems to the prongs, and you will see that automatically we have the prongs. Of course, we will have all the values to adjust. We can set, in this case, the depth. I'm going to make the depth from the extrusion. Actually, since it is a positive values, prongs will be upside down. I just make sure that X um, multiplied by -1, it will be negative. But I want to a little bit smaller. So actually, instead of -1, I will type -0.8 just to be a little smaller than the extrusion. So you will see that now it is connected, which means that whenever we change the value of the extrusion, the depth of the prongs will also update. And this is the reason I'm connecting existent slider to the new components to be able to relate all between each other. So once again, display material. In this case, I will select the prongs to the geometry, right click on the layer, and we will see the layer to be used. In this case, we just set let's use the layer number 8 for the metal layer, and we apply this to the prongs, and actually we can do exactly the same. Remember, shift for multiple inputs, and we connect the extrusion as well. I'm going here just to adjust here I need to adjust the prong taper to make sure it's a straight prong. So prong taper parameter set to 0. So right click and set to 0. Okay, and maybe I can also adjust here the horizontal, which I will type 0. Actually minus 0.05, and actually just to move the prong slightly in the horizontal. But as you can see, this is the the result. So now let's keep going, and I'm going to the settings to use the prongs on gem. Actually, the idea is to create the prongs for the central gem. You will see that we can connect here the prongs to the main gem. And what I'm going to do in here is to define the prongs size. Well, actually, first I'm going to connect to the display material. I want the metal layer, and also I want to use, because the halo gems are touching the outside prongs. I'm going to rotate the curve, actually the gem, use it on the gem curve to make sure it's aligned with the halo gems. So let's use here angle, right click and make sure it's degrees. The plane, it's the default XY. So what I'm going to do is to rotate the geometry and connect actually the rotated curve to the gems on curve. This will allow me to set the gems position. So let's type here an angle for the rotation, 15 degrees. We can see it's still not enough, so I'm just rotating maybe 20, still not enough. I want to the prong from the central gem to be aligned with the middle of two gems. So I'm going to use, let's type 22. Okay, seems good. Then we can either use this prong or and hide the other one. So since everything looks good, I'm going now just to make sure I want this depth from the prongs on gem to be the same as the extrusion depth. But once again, I need to make sure it's a negative value. So x multiplied by minus zero point 0.1 to make sure we are using the same, in this case 1.2, since I want a little bit bigger because there is the distance between the gems to the start of the halo. So I'm going to type, as you can see, 0.4 is probably too much, so sorry, 1.3 should be the good one. So this is the relation between this object. So I have my main gem. Of course, you can see we have all the other parameters that we can set: the prong thickness, the prong height, prong profile, everything. So once again, I'm hiding with the central mouse button, hiding the some of the components, and I'm going to keep going. And now what I'm going to do is to use the ring. I'm going to use the Bombay ring, and actually to start creating the shank. And what I'm going to do at this stage is to go actually to create a profile. So I'm going to the curves menu directly on Rhino, and I can set the curve. Remember to adjust the seam into the middle. So I just select the seam, enter to be placed in the mirror, and I'm going to use a curve. Double click on curve and type curve. So I set the curve, this one, and once again I internalize data, which means that I don't need the Rhino geometry anymore. I can delete it. So the curve is already on Grasshopper component, and what I'm going to do is to connect this to the both side profile and also to the top profile. So you will be able to see at this point that when I connect the profile curve to this ring, it's the one being used. And actually now I can delete the Rhino curve since I internalized data to the Grasshopper component, and I'm going to hide it. So now I just need to worry on defining the ring options. First thing is to connect the same ring size I was using. This is very important. So whenever we need to change the ring size, it's just one value affects all. And then I'm going to set the parameters of the ring. So let's type 10.0 for the top width, and also actually I need also one for the height. So I'm going to type 1.0 smaller than 3. So this is the range for the slider. So we have 1 millimeter thickness, and I'm going to also define the same thickness for the bottom. So actually the is side height, which will allow us to have the same thickness. And I'm going to drag with Alt on keyboard to make a copy. So now the side width, we can adjust the measurement. Let's type, drag the slider to 4.5. And once again, now I just double click and type 180 degrees. So this I'm going to connect to the angle. So this angle is actually where I want the ring start to taper, and we will see that this is the base ring, but we are now going to make some cuts on the ring. So the actually easiest way to make these cuts is to create a copy. So I just drag with the Alt key on the keyboard to create a copy, and actually I'm going to set an expression. So on the ring size, I'm going to multiply x by actually minus 1, which is the I want to a smaller ring size, but actually in this case they are the same because I don't need to multiply. Actually it just subtract. So instead of multiply, just x minus 1, which is defining minus 1 millimeter to the ring size. This is just for the Boolean operation. This second ring is just because I want to create some cuts, and with this cut, I'm going to set one expression, the same for the ring width. So let's say I want x minus 2 millimeters. So this is for the top. So I'm going to select here so we can see that the top it's minus 2 millimeters. And this one, the same expression, x minus 2 millimeters. Okay, so as you can see, we have a smaller ring. This will be my cutting object, and the height I'm going to, in this case, to make it higher. So x plus 2 millimeters, and the side height is exactly the same expression, x plus 2 millimeters. So why I use an expression is because whenever we change the original parameter, it's affected both, and then it will subtract, in this case, 2 millimeters. So this is my cutting object. The original ring is this original, the first one. The second one is will be my cutting object. So one thing I also want to use, and probably it's easier here just to create a box, is I want to make sure it's from the center. So I go to create a box, any size. Actually, it just matter to be on the C plane and goes down, because I'm going now to reference with the geometry. So double click geometry, and I set right click, set one geometry, and I select the box. So this box will be my cutting object. I just internalize data so I can delete the Rhino box. And then now I use this one. So now I'm going to double click and type solid difference. So I'm going to make Boolean operation. So the first object is the second ring, and subtracted with the box. So now you can see this my cutting object is just cutting in the top part of the ring, and finally I can do another difference, another solid difference operation with the original ring with this cutting object. So one object and the second object, I'm going to hide the previous operation. So you will see that now I have my ring cutted as I want. So this is the idea. As you can see now, whenever we change any value, it will automatically adapt everything. So this is the idea why I'm using all these parametric possibilities. And the next step, actually, if I want to adjust any measurement, because I set in the expression 2 millimeters, which means one for each side. So in the expression, if I want, instead of 1 millimeter, I want 1.5, I just type 3, which means that divided by 2, it's 1.5. So I will do the same for top and bottom. So instead of 2, I type 3 for the expression. So now I know these arms from the ring will be 1.5 millimeters. So whenever I change, let me just edit here the range of the slider to 15 maximum. Whenever I change, you will see that it will keep the 2 in this case 1.5 thickness for each side. Okay, so this is the idea. Now I'm going to adjust whenever value I use. So let's type maybe 5 millimeters for the bottom. So this is our ring structure. And now what I'm going to do, it's let's create a display material, and let's create a display material, and let's type in here the layer with a right click. Actually, it's not the number 10. I just see the layer for the ring is the number 7. So it's just for the display, and I'm going to now to make sure it is as I want. So I have the base of the ring, and now I need to place some gems. To place some gems, I will need to get the curves. Actually, I'm going first to get the curves from the ring to make sure I have the exact curves I need to place some gems. So actually, what I need actually before of the list item is the wrap edges. So I just connect my solid to these edges, and I select interior edges to this list item. So I will have a lot of edges. So I'm just creating here a slider to see which edge it is. So I'm going to connect this number 22. Actually, it is already the one of the two I'm looking for. So I'm going to extract the two outside edges and get the middle edge to place my gem. So I'm just going to copy the same, in this case, the list item component, and I'm going to look for the other edge. You see, when I drag the slider, I find, in this case, number 12. So I have the two edges I need, and now I'm going to use the twin curves component to get the middle curve. So one is the A, the two is the B, and you can see now I get the middle curve. So this twin curve is the one I'm going to use for the gem. So I can hide the previous components, and now this is the edge where I'm going to place my gems. So to do this, actually, I'm going to use gems on curve. So I'm going to give the curve is this edge curve, and also I need to connect one object, which will be my solid, actually my ring shank. So I just connect it to the object, so to orient the gems. And now we will be able to adjust the gems as needed, gem size and all that. First, I'm going just to use the display material. So I connect my gems to the geometry and right click on layer to set the gems number. Sorry. So now what I'm going to do is to define where is the start point and end point. So I don't want, let's use, this is from 0 to 1, the max from based on the curve. So I'm going to start with 0.05, and the endpoint, I'm going to do the same. So instead of 1, it's 0.95 to be the endpoint. Actually, I didn't type enter, so let's go again, 0.95. So we have the start and end points matching, and now I can type the gem size. So let's use 1.25. I connect to the gem length, gem width, and gem height. Remember the gem height to set an expression to multiply by 0.6 to keep the proportion. Okay, and now we have the gems with the size we want. We can keep going. So the next step, it will be, I'm going to create a mirror because I want to create a mirror from the curve to the other side of the ring. Actually, I just need to set a plane. I'm going to do it from the front view. It's easier. So from the center, and I adjust the axis. So I have one curve exactly mirrored to the other side. I can delete that curve. It was just for the visualization. And now click and drag with the keyboard to with the Alt on keyboard to create a copy. But now what I'm going to do is to use this second curve to place the gems. The difference is now that I can hide the mirror. Remember, central button to hide. And now instead of the same measurement, I'm just going to copy the slider because I want to use a different gem size. So double click and I can, let's try 2.2. I'm going to connect the same gem length, gem width, and gem height. And we have a different, I want to place the gems differently. So 1.8 millimeter size, and I want a different size, a different space between gems. So in this case, I'm going to use, let's say 3.0, create a slider to connect to the in this case I'm looking for the space between gems, so it's just a couple of gems in this side. And what I'm going to do is to I'm going to use the display material, so I connect the gems to the geometry. This is just for the visualization to be easier to understand. So once again, right click to the layer and the gems layer number 4. So now I need to make the settings for this gem. So let's go to these ones. I'm going to use the prongs on gem. So you can see it's 4 prongs by default for each gem. So this is the outside setting type. And actually what um, what I'm going to do is to make sure they will have exactly the length I need. So I'm going to define the same ring width for the depth of these prongs, and once again apply a material. So I'm going to change the layer. So this is for the visualization. So right click, I can see here each of the layers numbers. So I set the number 7 for the ring layer, and then I can use the prongs row for the other gems in the other side. So let's hide. So I will hide these ones because they are being displayed on the other component. And I'm going to place some gems here on this one. So let's use prong thickness zero point 0.5 or any other you want. And this is the thickness. The depth maybe can be a little bit smaller than 1. Let's type 0.6. Okay, so these are the prongs for the smaller gems, and what we will do is to adjust the prong taper to 0. Okay, so prong is straight, and I'm going to connect this to the display material, and I'm hiding this just to have the display it in the material. The same here. So I hide. Remember to hide is select the component and middle mouse button. So now we have the shank ready, the halo, and we are going to create the we are going to create the so I'm just checking if it is everything as needed. So now what I'm going to do is to create the a ring rail because we want to use half this top half. We want to place a chain. So I'm going to create the curve where is the chain is going to be. So first thing is to connect the same ring size slider. So remember actually to type ring size in this slider so we know this will affect all the ring size. So whenever I change this one, it will affect all the other ones. So this will be my ring size, and actually, as I want open distance, what I'm going to do is I'm just hiding this. I don't need. So what I'm going to do is to know the just need to hide because they are already connected to the display material. So less information is displayed. So what I'm going to do is to use the original ring size. I'm going to double click and type length. So I want to know this length of this ring rail. So this ring rail has a length of so is the output number. Actually, what I'm going to do is divide by 2. So I connect this length to divided by 2, and I'm going to use the result of this length divided by 2 as the open distance for my ring size. As you can see now, the ring it's open, and what I'm going to do actually, because I want it in the top, is instead of using the bottom, just create a mirror, and I'm going to use the ring rail to the geometry, but the plane I'm going to use the actually the top view. So 0 as the center and then adjust the axis. So actually it was not correct. So once again, right click, set one plane. The center is the 0 and adjust the axis for the mirror, which means that now when, let me hide this. So the mirrored geometry is on top, which means that this is the curve I need on top. And what I actually want to do is to make it a little bit higher just because that is the thickness of the chain. So I'm going to add to the ring size x plus 0.5 millimeters, then we can adjust. This is just because of the chain thickness. So let's use now the chain component. So I'm going to connect this geometry to the curve for the chain. I'm going to use the chain selector. I'm going to use we have some by default and we can add our own. So the number 5. So what I need to do now is to adjust the angle. So I'm going to connect this 90 degrees to the angle odd and even, and you will see that we are adjusting here the angle. I will also need to connect the one other slider. So let's use minus um, 1.5 to smaller than 1.5. So this is the range, and I'm going to connect to the elements distance. So it's in this case minus 1.5. So you can see it's the distance between the elements on the chain. And what we are doing next is to set one expression here for the ring size. I need a little bit bigger, so 0.6 uh, or 0.8. We want a little bit bigger to respect the ring size. So this is on the curve we are using as reference for the chain. So as you can see, looks good, respecting the ring size. Then we can adjust a little bit the the thickness and all that. So let's use maybe 2.2 for the chain thickness. And actually we can see it's probably even too long. So the division, instead of using divided by 2, I'm going to divide by let's type 2.2. So actually it's not bigger than 2. Let's type 1.8. So 1.6. I'm just checking. So the chain is not long enough. And so since I have the chain on the ring, what we are doing now, I'm just hiding the reference mirrored curve. What we are doing now is to, let's use now the display material for the chain. Actually, this is the chain, but before connecting it, actually I'm going to because I want to cut in the center. I don't need the entire chain. So to make the cut, I can do the auto cut. So I select the objects to cut the chain and the original cutting object. I'm going to use the center curve, actually the original central gem curve as a cutting object. So let me connect this to the cutting object. And now you see that I'm cutting let me just hide the other chain. I'm just cutting the chain in the bottom. So in this case, I can now create an under bezel to connect this part. So let's go to the component and under bezel. So you can understand what's being designed here. So once again, the gem will be the central gem for this under bezel, but now the distance, so it is, I want to make it connect at the finger rail. So let me use the distance to girdle. The What I'm going to use is this. I'm going to use the original distance to girdle for the gem. I'm going to use the same for this under bezel, but I need to take into consideration with the depth of the under bezel. So in here, I need to subtract the distance to girdle with the value I add in here. So let's say the depth is 0.9. So I just make sure I add here. So this will also be connected, the under bezel, to the chain. I can also, to make sure it's properly connected, then we can adjust the profiles and all the thickness and all that. I'm just going to make sure the horizontal distance is zero point 0.1, so to make sure it's connected. And now I'm going to connect the under bezel to the display material. So the outer part of my cutting object and the under bezel to the display material. So you can see what we are doing here. So make sure I put the layer number I want, layer number 7, and this is the idea. So here I'm hiding the components. Let me just undo to make sure I display properly the geometry, and I want to maybe create another one for the chain and other for the under bezel. Okay, I can hide, connect. This is the same process as before, and make sure I put the correct layer. and I connect the outer part to the display material. Layer number 7, okay. So this is the idea. All is connected, as you can see. Whenever I change something, all will be affected. So that's the idea of modeling these using components all connected to each other. Maybe in here I want a metal layer, so let me just change the chain to the same metal layer as the under bezel. Okay, so this is close to be ready, but I still need to connect this bottom part. Actually, the halo gems to the under bezel, and um, what I'm going to do here is to use. Let me double click on the canvas and type divide. So I'm going to create a sphere as reference. So the curve is the outside curve. I'm going to use number of control points. I want to use 4 because I'm going to create a sphere based on 4 points. So this original 4 points, I'm going to use a list item. So I want to have all the points, so I can add here points one by one. So all these are the points I've used. And now what what I'm going to use is the sphere with 4 points. So point 1, point 2, point 3, point 4. So we have a sphere. Actually, I'm interested in the bottom part of the sphere. So is what I'm going to use the what I'm going to create my connections. So actually in here, what I'm going to do is to move a little bit my sphere. So let's make a motion. Actually, the geometry is the sphere. And I'm going to connect the Z motion. So I want to move in Z direction. And actually, instead of 1 millimeter, it's -1. So I want to move the sphere a little bit down. And what I'm going to do is to use here the planar cutters, and I'm going to use the Z cutter. So I want to cut in half. So split brep, the cutter, and the geometry is the sphere I move, and the cutter is the Z cutter. Actually, it's split it in two parts. Now what I'm going to do is to use the list item to get the one I want. So list item. So I connect the two parts to the item. You will see that by default I have the 0, so it's the top one. So if I type 1, it will be the bottom. So I can hide this. So I have the bottom sphere as the result. And this is what I'm going to use as a reference to create here my bottom part of the halo, or a basket as you prefer. Okay, so this is the idea. Let's just then create here. Probably I'm going to create a line and then project that line. So the idea here is to make it in a parametric way. So that's why I'm looking for what should be the best approach. So what I'm going to do here is I'm going to actually what I want is the endpoint. Endpoint from the actually I'm going to use the outer curve. So this is the one. So I'm going to use this endpoint. So you can see there on green this endpoint. So I want to, this is one point to start my line, and I need another point to end my line. And that line I'm going to project to the sphere. That's the idea of this workflow. So now I need to get the, I'm going to actually, if I project to the project, I'm looking for the curve on ring rail, which actually, if I project the inner curve to the ring rail, it will be, I will be, I will have the, I'll be, I will have the endpoint as I want. So let me use now the line. Start and end point, so it's exactly as I want. So I project the original curve to the ring rail, and now I can hide all this. So I have this line, which is the line I want to project to the sphere to start creating the basket. Okay, so project, the item is the curve, the brep is the sphere that we just actually we just want to project. Let me set the direction, so the direction of the projection. So I'm creating the curves. Let me just check other directions to see the results. Direction. If you tap set on vector in Rhino, you set the direction of the axis. Okay, so let's project this to make sure we have the direction. I'm just trying here to use the rotate to see if it works better by rotating the original curve. I'm just seeing how the projection works better. Okay, set the direction. Okay, so let's see. Just trying to figure out the best approach here. So I just want a line to be able to create my metal along this line. So I want to project this properly, and let's see. the best approach. So actually I'm trying here now to create a copy of the original gem curve and set an expression to be a little smaller. So let's try x minus 1 and maybe it will result the result better for the projection. And actually what I need also is let me just figure this out. Vertical, so the offset curve, it's a little smaller, so setting the direction. So just a little bit tricky in this part. Just want to make sure it's properly projected. And actually, I'm going to create an offset instead of being the because there will be a thickness on this metal, and I'm going to define this distance as, let's type minus 1, actually 0.6 should be enough. So I'm going to use this as the surface to project, counting that I'm creating an inner surface, an inner sphere surface, to be the curve I want to project, because there will be then the curve thickness, right? So let's type probably 0.4 for the surface offset, and let me hide this. And now what I'm going to do with the curves, hide all the projection. I have the actually I'm going to create this metal on curve. So the projected curves I put here on the curve. Of course, I will need to adjust this. So the let's type 0.6, the slider for the width. So start profile width, mid profile width, end profile width, and another slider for the height. So width, height, and start, end, and mid. And also I will put it on the center of the curve, so this metal on along curve. And actually this rotation angle I'm going to set, let's use I'm going to set to all, mid profile rotation, end profile rotation, and start profile rotation. There are three profiles. So as you can see, I'm rotating my profile. So I rotate just to make sure it's fitting on the object. And now if I adjust either the thickness or the width, as you can see, it will adapt. So what I'm going to do is, let me reduce here a little bit the smooth cap. So instead of 1 millimeter, I'm going to use maybe 0.2, should be enough, and we can increase or decrease. But now this is one curve that I'm going to, what I'm going to do now is to create a polar array of this. So I will create this basket, but as you can see here, the polar array, before I will do the symmetry of my metal on curve. So when I do the symmetry, I can also connect it to the polar array. Okay, so let's see the result. Maybe I can adjust here the number of copies and all that. What's going on here? Let me just check number of copies. Um, make sure the plane is the central plane, and okay, the mirror, the original, and actually I think what might be missing here is to adjust the angle. Yeah, because it was on radians and I need to put on degrees. So let me make sure I will set it properly. I just undo and and okay, degrees, and let's use a degrees 360 degrees. Okay, now it should adjust better. So the number of copies we can adjust 4 or 6 or any other we want. Okay, so this is the idea. So this is the basket to connect to the under bezel, and I want also to adjust here the smooth cap of the original metal on curve, and seems good. So once again, display material, and let's connect, first hide this with a central mouth button, and then we can make the layer. Let's use the number 8, the metal layer, and connect this polar array geometry to the display material. Actually, when it's multiple objects, we can also do here right click and flatten all the input, so we can adjust it properly. It looks good. We can adjust here the profile, the angle, the rotation, and all that, but that's the main idea. And now we are going to create the cutters, just to show you that, because I create all these gems without cutters, so we can simply create the cutters as we want, and to make all these additional steps for the Boolean operation. So in here I just copy and drag the cutters, one for the one side gems, for one of the sides of the ring gems, other cutters for the other gems. So I can adjust here that the taper distance and all that. And so taper distance, um, we are creating the scatters to remove from the ring. Actually, just to show that we didn't create this originally, but any moment we can just come here, select the gems and also the halo gems. So I just, you can see here, we can easily adjust this cutter to make the Boolean operation. Once again, if needed, adjust here the taper distance, maybe zero point 0.4 to make sure the cutters are as we want. And finally, we can adjust also the rotation angle for the basket. But this is the idea. We can create these cutters, make the Boolean operation. This, I can hide this just to show you how it works. So in this case, we have our parametric ring, and then it would just be needed to make the solid difference. So once again, we select the cutter as the object to remove and the object to keep. We would select either the extrusion, so we would make the Boolean operation here to make sure when it's multiple we can right click and graph the objects to make the Boolean operation. But this is just to show you the idea. Actually, I'm going to central mouse button and freeze the component just to don't compute now, because this is the main idea, to show you the how it works. Let me hide or freeze the cutters. So all this is a parametric model. So any moment we can come here, whatever we want to change in, all will be related. That's why we create this grasshopper definition with all these components. So let's say that now I'm going to the original ring size and I want to change this ring size, let's say whatever. So double click and say 22, enter, and it will recalculate all the options, all the objects. Let's say instead now 15, it's computing to the 15 ring size. So this is the idea when changing 17. So parametric ring design. Hope you enjoy it. Thank you.